Let me explain about the angular displacement. We should know something about the angular displacement first. And when displacement takes place in a given time, that is called angular velocity. When there is a change in velocity, that is angular velocity change, it's called angular acceleration. So angular displacement, angular velocity, angular acceleration. Got it? So I'm going to explain about these things. Now, angular displacement. Let me consider a particle moving in a circular path. O is the center of the circular path. A is the position of the particle when t is equal to 0. And it has moved to the position B in a t seconds. Then it subtends an angle theta, and that theta is nothing but AOB. It's called angular displacement. But when you consider here at point A, V1 is the linear velocity here, and V2 is the linear velocity at B. Now let me consider the arc length, and that is the displacement in a circular fashion, is it not? So that is nothing but arc length. So we know theta is equal to this arc length divided by r. That is S is equal to r into theta. What is our OA? The radius. OA is equal to OB. So both of them are same. Next. Now let us consider angular velocity. Take down. This angular velocity can be represented as a vector omega. As I already mentioned, the rate of change of angular displacement is called angular velocity. So omega is equal to, we can give this in terms of a limit also. So limit delta t tends to 0, delta theta divided by delta t, that is equal to, when I say delta t approaches 0, what do you mean by that? Delta t tends to 0 means that is it is infinitesimally very small, in a shortest interval you can say. Therefore, in place of delta, you can use the instantaneous change in the position. So, d theta divided by dt. Any change taking place in the shortest interval of time can be called differential changes. So, d theta by dt is nothing but omega, and this is the angular velocity. And theta is given in terms of radian, and dt, that is second. So what is the unit of omega? That is radian. Instead of radian you can write rad, radian per second. Per second is represented as s power minus 1. Okay. So the direction of angular velocity is along the axis of rotation. So let us represent like this. Let me consider this is the axis along y-axis, you can say, and there is a circular motion like this. Okay, so this is the circular motion, and this is r radius, that is r vector. And what about this along the axis y? So here omega vector. that is angular velocity vector. So this is the direction of angular velocity. So the direction of angular velocity is along the axis of rotation. Which is the axis of rotation? Assuming that this is y. So y is the axis of rotation. This rotation occurs about the axis what? This y. Now let me talk about the angular acceleration. Angular acceleration. Angular acceleration is represented as alpha. As I already mentioned, alpha vector is the rate of change of what? Angular velocity. So d omega divided by dt. d omega divided by dt. So what is angular acceleration? Which is nothing but a rate of takedown, rate of change of angular velocity. So what is angular acceleration? Rate of change of angular velocity is called angular acceleration. In fact, angular acceleration is also a vector. Please note down this point. But this need not be in the same direction as that of angular velocity. Now let us talk about the tangential acceleration. Tangential acceleration. In fact, let me consider a circular motion like this, and O is the center, as I already mentioned. This is the radius r, and it subtends an angle delta theta, and this makes a displacement delta s, that is arc length. We can call it arc distance also, and that takes place in a given time delta t. So delta s is the arc distance or arc length. So arc distance or arc displacement, and delta t time taken for this displacement. R is the radius. Now we can define this delta s is nothing but r into delta theta. Delta s is nothing but r into delta theta. Now in a given time, in a time, given time means here delta t. Now let us differentiate this delta s with respect to delta t, that is delta s divided by delta t is equal to, and definitely this is r delta theta divided by delta t. In fact, as I already mentioned, it is an instantaneous velocity. We are talking about the instantaneous displacement in the shortest interval of time. So this delta can be replaced by d. Therefore, ds by dt is equal to r into d theta by dt. Got it? What is ds by dt according to linear velocity? That is v. And what about this r? D theta by dt is omega. Now we have obtained the relationship between linear velocity and angular velocity. So this is a very important relation. It is the relationship between linear velocity and angular velocity. What is V? Linear velocity. What is the omega? Angular velocity. Please take that. So this can be interpreted in terms of vector. So in that case, vector velocity, vector linear velocity vector is equal to omega vector cross, I'm sorry, that is r cross, first you have to put this one. V vector is equal to omega vector cross r vector. Okay, please note down. Please note down this omega and r vector are at right angle. Okay. Right angle means they are perpendicular to each other. Now, this dv by dt that we know. So, what is dv by dt? That is nothing but velocity. I mean change of velocity. So, acceleration. So, dv by dt is equal to, let us further build up this one from this. dv by dt is equal to r is constant but dw by dt. Okay. So in that case, this dv by dt is nothing but acceleration a. Is it not? This is the linear one at t time, that is equal to r, and dw, that is divided by d omega or dw divided by dt is alpha. So a is equal to r alpha. D omega divided by dt is equal to alpha. Therefore, A is equal to R alpha. Now we have two equations. One is V is equal to R omega and A is equal to R alpha. So this is called tangential acceleration experienced by an object. Okay. Let me explain with the help of a diagram. Now let us consider a circular motion moves like this. So this is the center of the circular motion. Let me consider R. From this, an object experiences a linear velocity tangentially, and that is the tangential acceleration. You can mention this as AT also, tangential acceleration. So this is O. Are you able to understand this? So a tangential acceleration is experienced by the body in a circular motion in such a way AT is equal to R into alpha. What is alpha? Alpha is the angular acceleration, whereas AT is the tangential acceleration.